The notion of complementary color is fundamental both in theory and practice. Two colors are complementary if they are diametrically opposed in the color wheel. But you guessed it, the problem is, what if we don't have the right color wheel? And what exactly is the right color wheel? We need a better definition. Theoretically, complementary colors are antagonistic. This means that one is composed of all the nuances of the spectrum that are missing from the other. Look at this example. Here are two complementary colors, cadmium red and cobalt teal blue, with a graph showing their spectral reflectance. As you can see, cadmium red covers most of the wavelength that cobalt teal blue doesn't cover, and inversely. The visual complement of a color can be physiologically determined by the phenomenon of retinal persistence. Here is how it works. I'm going to display a set of squares on a white background and ask you to stare at the dot in the middle for about 20 to 30 seconds. When I remove the squares, I'll ask you to keep your eyes on the dot, and if you want, you can let your eyes blur out. And don't move for another 10 seconds. Now, keep your eyes centered. You should see all the complementary colors appear. Red becomes cyan, magenta becomes green, and blue becomes yellow. This is how we define the visual complementary colors. Let's go even further and experiment with a painting. I'm going to show you a painting whose colors have been inverted. I'll ask you to check that the video is in full screen and to stare exclusively at the center of the cross. Move your head a little bit closer to the screen so that the painting covers most of your field of vision. Now, don't move and keep your eyes on the center of the cross. The picture will soon change, but I ask you to keep your eyes on the cross. Ready? From the corner of your eyes, you should see that the colors are back to normal. The red of the Christ's robe, the green of the forest, and of course the blue of the sky. Now, step back and look at the face of Christ. Yes, that's right, all this time the picture was in black and white. Surprising, isn't it? All this time you were looking at a black and white image, and the colors were just an effect of retinal persistence. Here are the original colors. In case you were wondering, this is not an effect of screens. You can do the same experiment with paint on a white surface. The phenomenon of visual persistence is an effect of our visual system, how it works. On a screen or with paint, here are the approximate couples that we can get. Red is complementary to cyan, yellow is complementary to blue, and magenta is complementary to green. It should be noted that these pairs do not work in the model where red, blue, and yellow are considered ideal primaries. In this one, the supposedly complementary pairs are red-green, yellow-purple, and orange-blue, and as you can see, they do not match the observations. Theoretically, the mixture of two complementary colors gives a neutral gray. Look at what happens when you add the spectrum of cadmium red and cobalt teal blue. The result is an almost entirely straight line. It means that it is composed of the same proportion of all shades. It's neither red, nor yellow, nor blue, nor green. In short, it's a neutral gray. Quinacridone rose is a quinacridone pigment that can be used also as a magenta primary. It is also transparent and it's a bit lighter than transparent magenta. Magenta is a family of pigment that has recently received a name, but has always been known as either crimson, pink, rose, or even violet. It is the only extra spectral color, meaning that it does not exist in the form of a single wavelength, but it is only perceived as a mixture of violet and red wavelength. It's the missing link, the hue that allows to close the color wheel. It's a very useful color because it offers blends that vermilion or scarlets cannot provide because they are too orange. Historically, the role of red magenta has been played by alizarin crimson. It's a pigment that's quite far from ideal magenta, but whose mixtures draw towards the magenta side of the wheel, so it's generally sufficient for portraits. Generally, you don't need to go very far in terms of chroma. Magenta is still not a very clearly defined color because it's not part of our daily vocabulary. In digital technology, magenta looks like this. In additive mixing, it's a mixture of red and blue light. Technically, the best pigment to match this hue would be cobalt violet. But cobalt violet is not an ideal pigment for painters because it is very weak and it doesn't bring much in terms of mixtures. Chroma is the second notion to take into account when thinking about color composition, and it is certainly the most important. Indeed, if all colors have a high chroma, the overall impression can quickly become shrill and unpleasant. On the other hand, if most colors are rather dull, but only one touch of a strong, vivid color appears, the eye will naturally be attracted to it. There's always been this idea in my mind that chroma is a little bit like sugar for the eye. As with sugar, it's important not to overuse it. In painting, chroma essentially has an exciting role. Bright, intense colors excite the eye, whereas dull colors reduce this impression. Chroma can be used to focus attention, it can be used to guide the eye, it can be unifying, or on the contrary, it can create a clash. As you might expect, it's all about balance. Imagine a balance. On one side, a very dull color is placed. On the other, a very chromatic color. The latter will make the scale weigh on its side. To regain balance, the duller color has to be larger and take more space. Now, what can we make of it? I'm going to do this project with oil paint on a linen canvas that I primed with gesso. In order to avoid painting on white directly, I'll try to find a background color that's close to the tones of my painting. This is called an imprimatura. I make a diluted acrylic wash using burnt umber, ivory black, and ultramarine blue. Although I'm making an oil painting, acrylic is handy for creating this background because it dries quickly. Be careful that this is only possible if the acrylic is applied before the oil, and never paint with acrylic after using oil. Another trick to give a color to this background is to incorporate some acrylic paint directly into the gesso before priming. Once this background is dry, I start the drawing with a white pencil. The advantage of using white chalk is that it can easily be erased and it doesn't smudge when the oil paint is applied, or at least it's not visible. Now I will start painting the trees and grass. And this particular range of colors that will allow me to create the dark atmosphere of the twilight. We will see that in this case, the green will have a very particular specificity. But first, let's see some important points about the color of vegetation. Foliage gets its color from chlorophyll. But behind this green pigment, there are many nuances. First of all, when we talk about chlorophyll, which green is it exactly? It depends on the light. When the leaf is lit by direct sunlight, it has a strong yellow-green hue, much closer to yellow than green in fact. In the shadow, the leaf takes a medium green, much bluer. This photosensitive shift is crucial for successfully painting leaves. These yellow and blue-green hues explain why most artists rarely use green pigments for foliage. Using a single green pigment can only create monotonous foliage that looks like artificial leaves. In my opinion, the key color for painting leaves is not green, but yellow. It's yellow that's used as the foundation for vegetation colors, not green. Remember what we saw about yellow. It's a color that can easily be changed. The slightest touch of blue or cyan mixed with yellow will inevitably give a green hue. And this is the type of mixtures that you need. It's also during this session that I'll start making glazes and semi-transparent velaturas. For this, you can see that I have added a pigment to my palette. Next to the opaque yellow ochre, I've added transparent yellow ochre. It's the same PY42 pigment, but with a very different look. This transparent variant will allow me to create warm glaze by adding transparent red oxide if needed. My goal for this session is to reinforce the warm side, especially on the top of the head. But I don't really want it to be excessive, so rather than repainting the forehead with, a bright opaque yellow, I will keep the color as it is and just glaze around the contours of the forehead. So I start by applying a light yellow-orange glaze around the hairline between the forehead and the hair. I simply apply a small amount of transparent paint that I delicately spread along the hairline.